And now we're going to do x-intercepts. X and y-intercepts. We're almost through it. We can do this. Our x and our y-intercepts, remember that our y-intercept was where it crossed the y-axis. So based off of that, we're going to say it's where we cross the x-axis is for an x-intercept. Basically, whenever we cross that line that we have drawn, that we say that this is an x-axis, so like right here, that would be an x-intercept. If we did something down here, that'd be a y-intercept. But when, like mathematically, what's happening is we're putting in an x value and we're getting out 0. So the way that we call that is we call these zeros of the function. Y-intercepts are going to be where we plug in 0 for x and we get out some number. We don't call these anything special, they're just y-intercepts because you only have one of them and it's crossing the y. Here, we're going to find our x-intercept and our y-intercept. Our x-intercepts are where? Well, they're wherever they cross the x-axis. And so the first one was at -3, 0. Remember that we have to include it as an ordered pair. So we're going over in our x minus 3, but we're going 0 up. And where was our other one? Well, our other one was at -1 and still at 0. And where do we cross the y-axis? Well, our y-axis, our y-intercept is at -3 because we're going down -3. But we're going over 0, so we're going to call it 0, -3. Here, we're going to have a lot of things. So we have 1, 2, 3 x-intercepts, but notice that we still only have one y-intercept. So let's do the y, well, let's do the x's. So our x-intercept, that looks about to be -7. So it crosses at -7, and that when it crosses, it's going to have an x value or a y value of 0. And then it's going to cross again, and it's going to cross at -3, and it's going to have a y value of 0. And over here at the very end, it crosses at 10, and it has a y value of 0. You notice that these are where it stops being positive or stops being negative. Now our y-intercept is, oh, almost there. Our y-intercept is just the one spot where it crosses our axis right here. Since it only crosses our axis in one point, it's going to be at 0, -3. The reason why you're only going to have one y-intercept is because one of the rules of functions is that when you put one number in, you have to get one number out. That means that if I put in 0, I am only allowed to get out -3. Then never, ever, ever am I going to put in 0 on this function and get out a 7. Because then suddenly we're not actually like being a code that we can use to replicate things. It's just a random choice, it almost seems. Which is why circles aren't functions. Fun fact for you all. So another quick check, you want to identify the x and y intercepts of each of these graphs. Go ahead and pause the video and do that. Now we're going to talk about concavity, and this one is an interesting one. You probably have no idea what it is, but I do have a picture of a cave, so at least it gives you an idea. Concavity is just the shape of the graph. We have two different terms that we can use. Math uses concave up and concave down. So this is math terms. This here, I'll do it in this color, is science terms. So convex or concave up is when the graph is pointing up. You're going to have a curve that looks like this. It's going to look like you could pour like water into it and it's going to look like a cup. Concave down is going to be the opposite when it points, surprise, down. Remember, concave is the science term, concave down is our math term, and that's what we're going to be using. And it looks like it's a cave, which is why we have a picture of a cave, because a cave has a beautiful concave down shape, or it's just concave in general. If it looks like a cave, it's concave down, or in science world, it's concave. If it doesn't look like a cave, then it's the other one. It's convex or concave up. Let's check out some examples of concavity, and these ones are nice and easy. I'm going to write on the actual thing. This one, it looks like it's going down. It looks like a cave, so we're going to call this concave down. This one is a little bit trickier, and I'm going to put in a caveat that knowing exactly where it flips is a calculus thing again. So we're just going to give our best guess. This little chunk here to here, this is concave down. This chunk from here to here, this is concave up. So a function can have multiple concavities, but really we're only going to have concave down and concave up. Finding the interval of these things is definitely not something that I want you to be worried about. Just be able to look at it and say that's concave up or concave down. So our quick check is to identify when the function is concave and convex, or in other words, when it's concave up and concave down. Go ahead, pause the video, and do that real quick.